Hello guys, welcome back to my YouTube channel. In this tutorial, we are going to resolve the following forces into their vertical and horizontal components and find their resultant. The question says, the following forces act concurrently on a particle. 60 Newton due west, 55 Newton at 50 degrees west of south, 30 Newton at 40 degrees east of south, 40 Newton at 180 degrees, 65 Newton north 58 degree east, 57 Newton north 62 degree west. Using analytical method, find the magnitude of the resultant force and state the bearing. Solution. The first thing to do is to make a neat sketch of all the forces acting on the body. We'll now draw our cardinal points. Here we have our north, here we have our south, here we have east, and here we have west. The first force is 60 Newton due west. Here is 60 Newton. The second force is 55 Newton at 50 degrees west of south. West of south. So this is 55 Newton and the angle is 50 degrees. The next one is 30 Newton at 40 degrees east of south. East of south. So this is where we have the force. And it is 30 Newton. The angle is 40 degrees. The next one is 40 Newton at 180 degrees. This 180 degrees is a three-figure bearing. Therefore, we start from the north and move in clockwise direction 180. Therefore, the 40 Newton force is acting due south. Here is 40 Newton. 65 Newton north 58 degrees east. North 58 degrees east. We have the force here, 65 Newton. Compass bearing north 58 degrees. Then the next one is 57 Newton north 62 degree west. We have the force here, which is 57 Newton 62 degrees west. Here is 62 degrees. So if you note very carefully, all the forces are inclined to the vertical. For this particular case, we are going to resolve the forces into their vertical and horizontal component using the angle of inclination of each of the forces with the vertical. So for this case, our H, which is horizontal component, is equal to F sine theta, and V, which is vertical component, is equal to F cos theta, where theta is the angle of inclination of each of the forces with the vertical. So our summation of H will now be equal to 0, such that forces to the right are positive and forces to the left are negative. Therefore, our summation of H will now be equal to. Note, you need to follow your sign convention, because any slight mistake by placing the sign where it's not supposed to be, your answer will be totally wrong. For this 65 Newton, if we close this angle by dragging this force down, the arrow points towards the positive direction. Therefore, the force is positive. So we have a 65 sine 58 degrees. This 57 Newton force, if we close this angle by dragging it down, the arrow points towards the negative direction. Therefore, this 57 Newton is negative. We have minus 57 sine 62 degrees. The next one is 60 Newton and is pointing towards the negative direction. Since it's a horizontal force, it has no vertical component. So we'll now say minus 60 Newton. The next one is 55 Newton. If we close this angle by dragging this up, the arrow points towards the negative direction. Therefore, our sign is negative. We have minus 55 sine 50 degrees. This is 40 Newton. It is a vertical force. It has no horizontal component because the angle of inclination theta is 0 and sine 0 is 0. So say minus 40 sine 0. The next one is 30 Newton. If we close this angle by dragging this force up, the arrow points towards the positive direction. Therefore, the 30 Newton force is positive. We have plus 30 sine 40 degrees. Therefore, our summation of H will now be equal to 65 sine 58 is 55.123 minus 57 sine 62 is 50.328. Then minus our, this n is not supposed to be here, 60. Then minus 55 sine 50 is 42.132. Then minus 40 sine 0 is 0. Then plus 30 sine 40 is equal to 19.284. If we sum up everything, summation of H will now be equal to, add everything up, minus 78.053 Newton. So our summation of V is equal to 0, such that upward forces are positive and downward forces are negative. So our summation of V will now be equal to the first force, 65 Newton. If we close this angle by dragging this to this direction, the arrow points towards the positive direction. Therefore, this is 5 Newton is positive. We have a 65 cos 58 degrees. This is 57 Newton. If we close this angle, the arrow points towards the positive direction. Therefore, this 57 Newton is also positive. We have plus 57 cos 62 degrees. Then the next force is 60 Newton. It's a horizontal force. It has no vertical component because cos 90 is 0. So we'll now say plus 60 cos 90 degrees, because this 60 Newton is perpendicular to the vertical. So we have 90 degrees. The next force is 55 Newton. 55 Newton, if we close this angle by dragging this force to this direction, the arrow points towards the negative direction. Therefore, the force is negative. So we now say minus 55 cos 50 degrees. The next force is 40 Newton. It's a vertical force. It has no horizontal component. So we have, and the arrow points towards the negative direction. So we have minus 40. The next one is 30 Newton. If we close this angle by dragging this force to this direction, the arrow points towards the negative direction. Therefore, this 30 Newton is negative. We have minus 30 cos 40 degrees. So our summation of V will now be equal to 65 cos 58 is equal to 34.445. Then plus 57 cos 62 is 26 0.760, then plus 60 cos 90 is 0, minus 55 cos 50 is 35.353, then minus 40 minus 30 cos 40 is equal to 22.981, so that our summation of V will now be equal to, if we sum up everything, minus 37.129 Newton. So if we draw our cardinal points again to locate the resultant force, here is north, here is south, here is east, and here is west. Our summation of V is negative, telling us that the force is acting downward. And our summation of H is also negative, telling us that the force is acting in this direction. So here we have 78.053 Newton, and here we have 37.129 Newton. So therefore the resultant force lies between the south and west. This is our arrow. The angle of inclination of the resultant force with the vertical is here. Let's call it theta. So if we close this part of the triangle to form a triangle, we say that here is equal to here and here is equal to here. Therefore, our arrow, which is resultant force, will be equal to square root of summation of H all squared plus summation of V all squared. Therefore, our arrow will now be equal to our open bracket minus 78.053 all squared plus open bracket minus 37.129 all squared, so that our arrow will now be equal to 86.434 Newton. To find our direction, we use tan theta. Tan theta is equal to opposite over adjacent, which is opposite over adjacent. This is equal to our opposite is 78.053. So I have 78.053 all over. Our adjacent is 37.129. 37.129. So our tan theta will now be equal to 2.1022, such that theta will be equal to arctan of 2.1022. Our theta will now be equal to 64.56 degrees. So to state the bearing, we say that the resultant force is 86.434 Newton on a bearing of 64.56 degrees west of south. Thank you.
If you find this video helpful, kindly do well to subscribe. Thank you.